So a quick recap of what we have been talking about in this particular case study. So we started off with this idea of studying intersectional groups, and there we were primarily considering four groups: the lighter males, lighter females, darker males, and darker females. We also talked about two benchmark datasets, and we saw how the authors actually went on and annotated these datasets for skin type, as well as gender level in this particular one. Okay, and we also saw that the authors made an endeavor to develop a new dataset which is much more balanced than the original dataset in terms of skin type distributions. And this is what they call the PPB dataset, the pilot parliaments benchmark. And here they were considering 6 countries, 3 African plus 3 European, Rwanda, Senegal, South Africa, were the African countries, and here it was Iceland, Finland, and Norway. And these were chosen based on the highest level of gender parity. Now, since this was a benchmark that the authors were preparing by themselves, they took a much holistic method in order to annotate this data. So, as I told you last day only, that they chose 1207 images which were annotated by 3 annotators. Unlike the other 2 benchmarks which were not theirs, okay, this one was their own data that they were releasing, and that's why they took a much more holistic method in order to get this data annotated. So they had 3 annotators annotating the data, okay, including the authors. This included also the authors. And of course, these data had to be annotated in terms of skin type as well as in terms of gender. Okay, so both these annotations were done by these 3 annotators. Further, the authors took an additional measure to actually make the skin type annotation for much more robust. Skin type annotation was actually further vetted by a registered dermatologist. Okay, so you see, they took utmost care. So that's why, like, when you call something a benchmark, you need to take utmost care while preparing the data. Otherwise, your benchmark data set will not be of much use. Okay, so that's why, like, the authors took a lot of additional care in order to build their own benchmark dataset so that it could be used by posterity for further experiments. And even to this date, people are experimenting on these datasets. Okay, so now for the gender, of course, the picture was the first clue. But other than that, whenever it was difficult to identify like fully from the picture, there are some cases where the picture is not so, not of a very high resolution and things like that. So in such cases, they also used additional metadata. And this is actually a good part of using parliamentarian data, because there you have a lot of good additional metadata. So this additional metadata included prefixes like Mr., Mrs., Miss, okay, and gendered titles. You know what are gendered titles? Any example?
Congressman or congresswoman, something like that could be.
Yes, congressman, congresswoman, lord, lady, etc. And of course, finally, names. So using all these together, the authors tried to infer the gender. Okay, and the authors obtained a very high inter-annotator agreement for both of these. Okay, for both these tasks, the inter-annotator agreement was good. Okay, so the data became acceptable for their experiments. So given all these factors, the data became acceptable for their experiments. Okay, so now we will see what are the different experiments that the authors ran in order to study the data sets as well as the different facial recognition systems which are able to classify gender. So recall that they had two tasks. One was distribution of skin types in the data. This is one thing that they studied. And the other is, and the corollary of which was this new data set that they prepared. And the other one is the testing of gender classification softwares based on input facial images. Okay, so these were the two tasks. Now let us go ahead and look into what they have done. Okay, so the first thing that they studied, let me see some mess with this. Is this table. You are able to see the table, right? Big enough. Can you please confirm?
Yes, sir.
Okay, fine. So now, as I told you last day, that they had this categorization of the 1, 2, 3 subcategories of the Fitzpatrick scale as the lighter skinned ones, and the 4, 5, 6 of the Fitzpatrick scale as the darker skinned ones. So from this data set, from these three data sets, what is your immediate observation? So if you remember, the IJVA was having 500 unique faces, Adians was having 2194, and there the authors, okay, I made a mistake. That was 1270, not 1207.
In all the cases, lighter percentage was more.
Okay. Anything else? Which one would you consider to be roughly acceptable among the three?
PPB one that they contributed. So
Yes. So that is the reason. So this is why they are telling that the data set, that this new benchmark was necessary. So this was their point of like contention with the previous benchmarks. So if you observe carefully, the lighter skin population is like way higher than the darker skin population in these two data sets. Okay. Comparably, the PPB dataset is far more balanced. Okay. So they went one step further to see. So look at this picture. This is a very interesting observation. So they went on to see further the population distribution in the three datasets as per their intersectional categories. So you recall the four intersectional categories that we are talking about are darker female, darker male, lighter female, lighter male. And these are the three datasets. What do you observe here?
their data set is balanced on both axes, the gender and skin.
Okay, anything else? Something strikingly
PPB dataset has nearly same all of the four categories.
yes, that is true. Okay, so one thing, see the IJBA dataset. It's pathetic, right? 4.4% darker males. Okay, and here again, Adians for darker females, it's 6.4%. These are like pathetic numbers given the whole distribution of the data. And as you have
4.4%, sir,
rightly,
darker
huh?
female, right? 4.4% is darker female, right?
Okay, I'm sorry. This is So I'm just mixing up the colors. Just a mistake. So this is 4.4% darker female for IJBA and 6.4% darker male for ADNs. Okay, so the essence of this whole thing is that in general there is low representation, and also darker females have an extreme low representation in the IJBA dataset. If in fact if you see here, the differences between the darker male and darker female is not so high, it's just 1%. However, here the difference is between these two categories also is very high, and like the darker females are extremely less represented. However, as you have pointed out very correctly, that in the PPB dataset that they developed, actually most of the intersectional groups are, I would say, pretty well represented. Okay, so this was one of the primary motivations for developing this new benchmark. Okay, so now they have given also further divisions of the dataset. Okay, so this is how the entire data set of the PPB benchmark can be categorized. And what do you see here? Some observations from here. So one of the important points in this course is to make observations from your, make insights and observations from the empirical results that you obtain. And this is why we are doing this exercise. So among the African population, the population from Rwanda has zero representation from the lighter males and females. Okay. Similarly, in Finland, you have the smallest representation of no representation from very low representation from the darker skin type group. Okay. There is one more thing to observe.
South Africa has some from both, like all categories.
South
That
Africa has like quite a nice even distribution. I mean, compared to all the others, compared to all the other countries, South Africa has a better representation from all the groups. Anything else? Of course, for the countries that they have chosen, there is a good gender parity. Anything else? as I told you earlier, Rwanda has a larger female, much larger female representation in the parliament compared to males. Okay, so these are roughly the major observations that one can draw from this particular table. Next, so as I said that after this, the authors went on to study commercial softwares, okay, and their gender detection performance given the facial images as imports. Now they did their experiments on the PPB set data set because it is the balanced one, and like if you do these experiments on the other two benchmarks, the results inevitably would be biased. So that's why they chose the PPP dataset for their testing of the commercial softwares. Okay, and they used three commercial softwares. The first one comes from Microsoft. The Face API of Microsoft that they used. The second one is from IBM. You remember I talked about Watson. It has a facial recognition stack in it. And the third one was Face++. So these were the three softwares that they used in order to test their gender detection performance. Okay. And the results of this is summarized in this particular table. Now this table has a lot of interesting observations, and we will particularly use quite a bit of our time today in understanding this particular table. Okay, before that, let me remind you that PPV, anybody knows what is PPV? It's the positive predictive value. And it is defined as true positives by true positives plus false positives. So what is it? What is its common name? By what name do you know it?
Precision.
Yes. So this is the precision. So the other name of precision is positive predictive value. Okay. And the authors define error rate as 1 minus the positive predictive value. Okay. So this is the error rate. And apart from that, they also measured the true positive rate. Okay, this is what I already defined. So true positive rate is also, you know what is it?
Recall.
Recall. Okay, as well as the false positive rate. This I have already defined in the previous class when I was talking about the ProPublica case study. Okay, so now given all these measures, we have to summarize the insights from this particular table. So what are some of your important summaries? what is the first notable thing?
Face plus plus software
MSF
having
Face software.
having
See,
highest precision and lower false positive rate in
uh,
darker mail.
okay. So whenever you are looking at a table or whenever you are looking at such large empirical results, the first mantra is to find out universal patterns. Start with finding out universal patterns and then slowly deep dive. So there is one universal pattern that is featuring.
Sir, darker females, they have very large error rates and false positive.
Absolutely. That is the most important point of this table. If you see any of these softwares, darker females have the largest error rates. So this is the first point. Okay. Now, now start deep diving. So for the Microsoft, as you see, the bold numbers will tell you most of the insights. For Microsoft, as you see, lighter males have 100% precision. Okay. Whereas lighter females have 100% recall. Fine. And both of them have high opposite things also, like recall and precision. Okay. So overall, for lighter males, lighter females and lighter males, lighter females and lighter males, you have a high F1 score. Okay. However, this is not very true for the darker females. So the darker females, of course, the error rate is very high. Anything else? Anything else that is notable about darker females?
Sir, false predictive
The
rate.
false positive rate is also very high. Okay. The false positive rate is also very high. Similarly, for face plus plus, as we have seen, for the darker females, the error rate is high as well as the false positive rate is very high. Okay. Again, in this case, lighter females and lighter males have an advantage of having high precision and recall. There is one good part about face plus plus, that is the darker males also have a very high precision. Compared to the darker females, it is actually much higher. See, this is only 65%. Okay. All the others are 90 plus. So the darker females are extremely ill represented in these softwares. So, okay, once again, one good thing about this is, if you call it a good thing, is that darker males have high precision. And in the IBM one also, once again, the lighter males and the lighter females are at a much higher advantage, and as usual, the darker females are actually highly ill represented, okay, with a very high false positive rate as well as a very high error rate. Now tell me, like, although these are like black boxes to us, these algorithms are black boxes to us. We do not know how they are functioning. But can you hypothesize at least like what could be going on? Why are the results on the darker females so poor? Any thoughts on this? So this was why last day, as you saw, Joy's face was not getting recognized. This is one of the reasons. Of course, this is a very simple experiment that they did where they were trying to identify gender, but like this goes on for other attributes also. Why do you think this has happened? Of course, we cannot make a 100% direct claim because we do not know how the algorithms are built, but we can make some guesses. And what would be your guess?
The training data would not have been balanced.
Okay, number one, training data is not balanced. So basically, you are telling that low representation of the darker females in the training data. Anything else that you can think of? Any other point that comes? So, okay, this is the data level thing. So last day, one of you were asking whether there could be some model level things. Can you think of, or do you think there could be a model level bias? And if it is, what could it be? So all these systems are using some sort of an ML or a DL architecture. Okay, a vanilla ML or a DL architecture. Do you think there could be some problems out there? Could there be some issues with the model itself?
Yes, sir. The models could have been inherently trained on maybe wider
No,
images.
that is again you are coming back to the training data problem.
Yeah.
But as a model, could there be something that could be bothersome? Think of vanilla ML. Don't think of DL at this point. Think of vanilla ML.
Like if it is based on feature engineering, the
Feature
features and
engineering, very good. It is based on feature engineering. Then
so like there might be some inherent bias in the way the features are like determined
tell me
from the
what in the inherent way. You are very close. This will actually set our footing for the next few lectures where we will like study how to debias machine learning algorithms. But tell me like what do you think could be some like lacuna in the features?
it- maybe they are relying on something like all females need to have long hair or something and it might not hold. So I don't know.
Very good. Very, very good. So basically, you are telling that there is in the feature construction, the model has factored factored a spatial attribute. Okay, in most cases, as you will see, like probably in tomorrow's lecture we will talk about this. In most cases, this spatial attribute is called a sensitive attribute. Like just now you said that the model might be considering that somebody with a long hair is a female. So there is some spatial feature that is getting associated with a sensitive attribute, which in this case is gender. So gender could be a sensitive attribute. Skin type could be a sensitive attribute. There are quite a few other sensitive attributes which we can talk about in tomorrow's class in details, but this is the basic idea. So in the feature construction, some sort of sensitive attribute might have been factored in, which should ideally not be the case. Okay, so this kind of unknowingly including sensitive attributes, sometimes even knowingly. Okay, so and there are justifications for that. We will talk about these in details. So which will bring us into like an area where AI will have an intersection with some parts of law that we will talk about in the next. That's why we are doing this course, and that's how the name of the course is justified. However, like for the time being, assume that there could be some sensitive attributes that might be associated with the construction of the features, and that's how a model level bias could also be introduced. We don't know what is happening. It might be because of the training data, it might be because of the model level bias. Okay, so now the authors went on after this with an additional experiment where like they pointed out that these results might be an artifact of the images in the African parliamentarian data set being a little lower, being of a little lower quality. So basically, some of the images of the parliamentarians taken from Senegal and Rwanda, those were like of not very high quality, and the authors pointed out that this could be one of the reasons why the gender detection was not happening correctly. So therefore, they subsetted their data and just looked on the South African data set, okay, which was like much, as you saw, which had a better balance, as well as this data set actually had very high resolution pictures comparable with the pictures of the parliamentarians of the three European countries. Okay, so that's why they subsetted their results on the South African data set. And the observations are pretty similar. Once again, as you see, the error rates for the dark female as well as the false positive rates for the dark female are still very high. So basically, dark female still suffer from high error rates and false positive rates. On the other hand, the lighter males have full precision and full recall. Okay, for the Microsoft dataset, for the, so this is happening. You see this, there is so this is like spotless because the pictures here are actually of very high resolution, and therefore the software is like for the lighter females and lighter males, the software is like doing the like the is giving the best performance. So for even for Face++, you have like 100% precision and recall for the lighter females, and 100% precision for the males, whereas 97% recall for the males. Okay, similar is the situation for the IBM dataset. Okay, very high. However, if you see here, still, even with so high resolution pictures, the precision, even the precision, the error rate is high and the precision equivalently is very low for the darker females. Okay, so there is some intriguingly wrong, like, or some intriguingly inadvertent thing is going on in these softwares. So like, if it was only because of the image quality, then it would not have featured in this South African subset, but it featured equally well in this South African subset. So this also shows how robust the results were. Okay, and therefore the observations and the insights that the authors made are actually, like, quite uh, believable. Okay, so in addition to this, they also did some small experiments, like for the IBM Watson. What happens is, in this particular facial recognition software, along with the detection label, there was a confidence score associated. And the authors, along with the detection label, also plotted the confidence score in terms of box plots. And this is the result. So what do you observe? Most confident, where is it most confident?
Light skinned males.
Light males, followed by light females. And it is least confident with the dark skinned females. So you see, it's not only about the level predicted, but also the confidence with which it is predicted is very low in case of dark females compared to the other three categories. Okay, so there is some issue probably going on in the training data. So this is one indication that probably there is some issue with the training data, as we were also hypothesizing. Okay, this less confidence is probably further indicative of that there is a disproportionate like training points in the decision making software, okay, from which the decision making software has been trained. Okay, so this is all about this paper, and I am not going to start anything today further, but there are a few announcements. So the first thing is, I have told you multiple times, please join because all the important information from now on will be posted on the Google group. Okay, so then, as I had already announced in the first class itself, that we will have term projects So please start forming groups. Four to five members, not more than that. Okay, please start forming groups of 4 to 5 members, and the lead, you should elect a lead from this, should send a mail to the TAs, okay, with the group consistency. Okay, so who are the members of the group, and like who is the lead of the group? The lead should send a mail to the TAs. Do not flood the TA inbox with each and every one's individual emails. It should be only the lead who will give the information about the group. Okay, so we will have around, I am hoping, 13 to 14 term projects from which you will have to choose. We will give you the exact instruction as to how and when you will have to submit your options. Once you submit your options, we will connect you to the respective mentors, and the mentors will give you the necessary materials for progressing with the term project. But most of these term projects will require you to do some data handling as well as writing small pieces of codes. Okay, so some of the earlier term projects have resulted into even very good papers in very good venues. So if you do this well, like, we can come up with a lot of interesting outputs. The next and a very good information is that we will have 3 confirmed invited lectures. So all these 3 will be sometime in the month of March. Okay, so the speakers would be, if you are interested, you can go and visit their profiles. They're very well-known people. Srijan Kumar from Georgia Tech, Kiran Garimela from Rutgers, and Juhi Kulashrestha from University of Constance. So Srijan will be talking on cyber safety. Kiran will be talking on content governance. With special stress on fake news. And Juhi will be talking on AI and policy. So all these talks are going to be there, all young faculty members in different places across the world. All these talks, I hope, are going to be very interesting. So I would like invite all of you to stay tuned, and like this, all these 3 talks, I am planning to schedule them sometime in March. So all the talks will be spread across the different like weeks of March. So if possible, I'll try to like consolidate them into 1 week, but it might not be possible given the constraints of the speakers. But hopefully we will have all 3 of them during the month of March, when we are already doing the content governance part. So these 2 talks will be mostly about related to the content governance part. So, and the AI and policy talk will be around fair ML, mostly designing fair machine learning algorithms. Okay, so that's all about the announcements. So I would request that you please form the
Sir,
groups. Yes.
sir, can we make group of 6 people?
No, I would recommend to make something between 4 and 5. If there is one person who is left out and cannot form a group, in such special cases, we can allow 6.
Okay.
Okay, so we'll stop here and tomorrow we will start with bias definitions. Any questions?